colloids. A colloid is a heterogeneous system in which one substance is dispersed phase. Dispersed phase is equivalent to solute, a very fine particles in another substance known as dispersion medium. Dispersion medium, we can say, is analogous to of a solvent for solutions. It's a dispersed medium and dispersed phase. Particle size of dispersed phase is 1 to 1000 nanometer. So one thing we have to remember, it's a heterogeneous system having two constituents, dispersed phase or solute, dispersion medium or solvent, their analogies. Minimum size of colloid is 1 nanometer. If particle size is smaller than 1 nanometer, it will turn out to be a true solution, and maximum size possible is 1000 nanometer. Just by analogy of a water molecule, which having a size of 1.52 angstrom, and 10 angstrom is 1 nanometer. So a particle with 1 nanometer, if we divide it by the volume of water molecule, considering it is sphere, we get roughly 296 such water molecules in single colloidal particle. It's just an analogy to give you approximate that how these small subatomic particles combine to make colloids. This is how the colloid is. Colloidal particles are larger than simple molecules, but small enough to remain suspended. If the particle size is greater than 1000 nanometer, they will tend to settle down with time in solutions, but that is not the case with colloid. Colloidal solution will remain suspended. Colloidal particle will remain suspended in dispersion medium. We can classify colloidal solutions based on physical state of dispersed phase, that's our colloidal particles, and dispersion medium. It's a medium in which colloidal particles are suspended. Or the nature of interaction between dispersed phase and dispersion medium, because to stabilize the colloidal solutions, it's important that dispersed phase and dispersion medium interactions able to hold colloidal particles suspended in solution. Finally, type of particle that dispersed phase is made of. This is the way we explain it. Physical state of dispersed phase and dispersion mediums. We can classify colloids on the basis of this dispersed phase and dispersion medium. First, we'll talk about dispersed phase or solute. We can analogically say solute. Its basically technical name is dispersed phase, and it is suspended in dispersion medium. First, solid is a dispersed phase. Dispersion medium is also solid. Type of colloid is solid, sol. Colored glasses and gemstones, they are examples of these colloids, solid and solid. Next is solid dispersed phase in liquid dispersion medium. Their paints are examples of such cell fluids in our body. They are examples of solid and liquid. Solid and gas, our smoke, whatever our vehicular emissions, they are example of such thing. Or we can say very fine dust that remains suspended in air, smoke. Next is liquid dispersed phase in solid dispersion medium, cheese, butter, jellies. Basically, dispersion medium is a solid, only liquids are suspended in that. That's why these are the examples. Next example is liquid is a dispersed phase, dispersion medium is liquid. It's basically one for sort of emulsion. Milk is a wonderful example of this. Liquid dispersed phase in gas, aerosols, our deodorant spray are examples. Fog is an example, the clouds are example. Next is gas is a dispersed phase in solid. Stones, foam, leather, rubbers are examples. Gas in liquid. Gas is a dispersed phase. Dispersion medium is a liquid. Foams are example. Froth formed or whipped cream. Whatever our hand wash, sanitizers, leather, they all are examples of gas in liquid. So these were physical state based. What is the state of dispersion medium and dispersed phase? Now we'll talk about colloids based on nature of interaction between dispersed phase and dispersion medium. Let's talk about it. Two possibilities are Lyophilic colloids. Lyophilic means solvent loving, solvent attracting. Lyo means solvent, philic means loving. So those colloidal solutions in which dispersed phase having a great affinity for dispersion medium known as lyophilic colloid. The interaction between dispersed phase and dispersion medium are stabilizing the colloidal salts, and these salts are reversible as if we mix it, here we see it's a dispersion medium, we mix it with a dispersed phase, we'll get gel, which is a lyophilic colloid. Now simply, if we heat it up, what happens is gel will lose water and we get dispersed phase back. Gum, gelatin, starch, rubber are certain examples of lyophilic colloids. Now, opposite to the lyophilic is lyophobic. Phobic means hating, repelling. Again, solvent repelling colloidal solutions. In the lyophilic colloids, interaction between the dispersed phase and dispersion medium are not stabilizing the colloidal solution. Means we can say they are basically unstable colloidal solutions. Because they are unstable by the very nature, these can be readily precipitated or coagulated with addition of small amount of electrolyte by heating or sometimes by simply shaking. Lyophobic source examples are ferric hydroxide, aluminum hydroxide, and arsenious sulfide. As we discussed, lyophobic colloids are unstable by the very nature. So to stabilize such colloids, we have to use colloidal stabilizers. that covers or smear the surface, and by covering it, they protect it from adhering together. Colloids are classified based on particle of the dispersed phase as well. So far we have discussed colloidal classification based on state of dispersed phase and dispersion medium, interaction between dispersed phase and dispersion medium. Now, third category is solely based on dispersed phase particle types. Let's see. First is multimolecular colloids. What are these? When large number of atoms or small molecules with having a particle size smaller than 1 nanometer combine together in a dispersion medium to give a aggregated large size particles which have size range in colloidal solution range. They are known as multimolecular colloids. Many metallic or non-metallic elements salts are known as multimolecular salts, like gold salt, sulphur salt are examples of multimolecular salts. We'll discuss about their preparation a bit later. So multimolecular colloids formed by the combination of small size particles to give a particle in colloidal range. Next example is macromolecular colloids. So what are macromolecular colloids? These macromolecular colloids on dissolution of macromolecules on dissolution in suitable solvent form solutions in which the size of macromolecules may be in colloidal range. These colloids are quite stable and resemble true solutions in many respects. Starch, cellulose, protein, enzymes, colloids are known as macromolecular colloids. Macro mean large, molecular as you know. So these are the colloidal solutions of large molecules. Naturally existing large molecules are proteins, enzymes, starch, cellulose. Third category is associated colloids or micelles. Let's see it. Micelles is an aggregate molecular assembly dispersed in liquid. Many electrolytes at higher concentration lead to the formation of micelle aggregates. Formation of a micelle takes place only above a particular temperature known as Kraft temperature, TK denoted. And the concentration, particular concentration is called critical micelle concentration, CMC denoted. So here we see micelles is an aggregate molecular assembly in dispersion medium, while here multimolecular colloids was again combination of small particles to make colloidal particle size. So here will be certain differences between associated colloids and multimolecular colloids that we are going to discuss a bit later. But important point is these don't having a multipolar entities in atoms, but in associated colloids we do see dipolar ends. Now let's proceed further. Multimolecular colloids, we know sulfur salts and gold salts. This is an example of a gold salt. In nanochemistry, it's basically about particles on nanometer scale. This is a gold salt of small particle size. You see color here. But as these gold particles start combining with each other, it makes larger gold particles. color will keep on changing. You see here, then it's gone to almost velvet. This is because of the different colloidal particles. Macromolecular colloids, simply we discussed, these are made by the large molecules like proteins, enzymes, or cellulose, starch, etc.